How's it going? Yeah, so the best thing about being a software developer is you can work wherever. So if your wife has a job where you get to travel around, then travel around with her, right? Anyway, so I am Taintor, and I'm here today to talk a little bit about Chef and why you might use Chef and how you go about using it in your organization. So first I have a few questions. So raise your hand if you are manually configuring machines for your testing environments or for your production environments or that kind of thing. All right, raise your hand if you're familiar with tools like Chef or Puppet. Well, okay, and raise your hand if you think you're an expert in Chef. So we have a few people up there. So I will go ahead and say that I am not an expert in Chef, and so you might be wondering why the hell I'm up here. And the reason I wanted to come and talk was about why we wanted to use Chef in our, at Klarna. And then once we've kind of talked about that a little bit, then basically how you might want to go about using Chef so you don't make a lot of the mistakes that people make when they first start out with Chef. So a few notes about Klarna. Klarna is a Swedish company, and they have an office here in Israel. And they've been here for been in Israel for about 2 years. And we are expected to take care of all of our machines. So that means configuring them and taking care of them, also coding front and back and all that kind of stuff, right? So basically how we have been working was that, at the beginning there weren't that many people, so we were concentrating on getting things done really quickly, so we were doing things by hand, and this led to a lot of problems. Some of the more obvious problems are that if we had a machine that was configured 6 months ago, we didn't really know, we couldn't really replicate exactly how it was made, now. So that was, one problem. Another problem is that when you actually went to machines and you saw how machines were configured, you didn't have any idea as far as why it was configured that way. Like, was there a great reason for it, or did the person that was doing it really not know what they were doing, or all that kind of stuff, and you didn't know who you could go talk to. The last thing is that for me, what really got frustrating was when we tried to make changes to a staging environment, and then we tried to push that onto production, and that didn't really work. And it led to these really painful things where you have to go to each machine, you have to be checking it, and see what kinds of changes you need to make to get the same thing to happen on each individual machine, which is very error-prone and stupid and annoying. But unfortunately, you end up doing it at some point. So basically, we decided this really wasn't working for us. So we started looking around, and there's this whole cool industry buzz term called infrastructure as code. And the whole idea here is that you have text files that describe what your machines will look like, and then those text files are run on some system runs those, and it decides and it configures your machine. And of course, the cool things you get with this is that you get automatically you get traceability, so you know who made a change when, because all this stuff is in Git. You also can start using a lot of things that other people are doing, so you can gain from the community. The other thing is that you can apply the same kind of workflows that you have with your code to your infrastructure. So you can have code reviews, you can be testing things locally, push them to different environments, and then on up the chain so that when it actually goes out of production, you feel pretty good about it. So we started looking at this, and we started looking at multiple tools, and the two big tools that are out there are Chef and Puppet. I could sit up here and say that we spent days or hours or whatever trying to figure out which one of these is better, but we really just went ahead and chose Chef. Chef is, the Chef client at least is written in Ruby, so it feels pretty natural. Also with Chef you get to make all kinds of fun puns, and it's really great when you go to Google and you search for Chef, the first thing that comes up is not the tool. And anyway, any gem you ever download for Chef is going to have some crazy name that's related to cooking, which is fun. Anyway, but if you start looking at start reading about Chef, if you're not familiar with it, you start looking at it and it sounds really great. You can have 10,000 machines all organized, all provisioned at the same time with the same configuration, and it sounds great, right? But of course, if you've used Chef, you've got out there and you realize that the beach doesn't really look that pretty, and that it's you start asking yourself, why did you get that way? Or how did things end up that way? And a lot of times it's because people have this idea, they start reading about what Chef can do, and so they have this idea that they're going to create this amazing piece of engineering, that has that's really complex, and but it's just a push button, and everything just works magically, But ultimately, what happens along the way is that instead of this amazing piece of engineering, you end up with something that still gets you there, But looking back, it'd probably be better if you had some motors and you had a full handlebar and that kind of thing. So really, a lot of this comes down to where should you start. So a lot of people will, make things more complex than they need to. So basically, we started thinking about this, and we talked to people about problems they were having with Chef or whatnot. So we started thinking about what was important to us. So there are basically like 4 big things that were important to us. Obviously we needed a tool that would allow us to have reproducibility. We needed a tool that where we could test. We had a tool that had traceability, and then also we wanted to follow the engineering ethos of keep it simple, stupid. So with all that in mind, we started our forays into Chef. So if you don't know anything about Chef, which a few people here don't have experience with Chef, basically the basic concept of it is that on a given machine, Chef will figure out what needs to be run, and then it will run it in an idempotent way, which is a very fancy way of saying that if you run Chef one time, if you run it like 10 times, it'll be the same as running it one time, assuming there are no configuration changes. So if you make a small change, only that change will go out, and only things related to that change will be affected, but nothing else will be that way. So basically, you can run Chef, and it may take 10 minutes or something like that to do all of your configuration, but the next time you run it, it will take, on the order of like 5 seconds or something like that. So to get into kind of the basics of Chef, Chef at the base level is centered around cookbooks. And cookbooks are kind of a container for everything that you might need to configure a specific component. So an example of that is that you might have an Nginx cookbook, you might have a MySQL cookbook, you might have Ruby cookbooks, all that kind of stuff. So it's all like everything needed to configure a single component. And now a cookbook itself is actually just a directory structure, right? So it has directories, it has files in there, but if you create a blank cookbook, these are all the directories you have. So if you look at it, you have attributes, definitions, files, libraries, providers, recipes, all this stuff, right? But you don't really need to know all that. Of course, Chef is a complicated tool, and it allows you to do a lot of things, but if you're trying to learn it at the beginning, you shouldn't be looking at all these complicated things, especially because it's going to be a while before you're actually going to start using them, like building them. So basically, you can focus on 2 things in Chef, which are attributes and recipes. So the best way to explain, how these things work is that if you look at like the Nginx cookbook, you notice it doesn't have all the same files or directories that the other one did, so it doesn't have to have everything. But then on top of that, it has the main core things that you need to know as a user of this cookbook are the various recipes and the various attributes. So if you're looking at these recipes here, like every Chef cookbook will have a default recipe. And basically what that means is that when you're referring to using a recipe, you can refer to the recipe as the cookbook name, so it's shorter, and whatnot. And a lot of cookbooks might only have a default recipe. But the difference between the default recipe and the non-default recipes typically are different flavors of the same thing. So if you're talking about Nginx, the difference between the default recipe and the source recipe is that the Nginx default recipe will install it using a package, whereas the source recipe will obviously compile it from source. And then the same kind of thing is true with attributes in that all the default attributes are attributes that are necessary to run the default recipe, and in that file it will have all the different settings that you need that you can configure. So it might be like where Nginx is installed, the types of things, like maybe what the default site will be enabled, all those kinds of configuration things. And then the source one would have the extra configuration you need just for source. So that's kind of the basics of the cookbooks. But of course, once you have that, then what do you want to do? So for a really simple case, you might want to create a machine that has three things on it. So it might have Rvm, it might have Nginx, and it might have some users. And I'm using Rvm as an example here. Don't really want to get into flame wars about Rvm. But anyway, so in this case, we have a run list, and this run list basically describes the 3 things I might have on the 3 things that are going to run in that machine when the machine is configured using Chef. So this is basically saying, that I want to run the Rvm system recipe, which is a recipe that will install Rvm as a system user. The other one is Nginx, which is the default recipe, which will do it with a package, and then a user one, which I won't really talk about, so just assume it creates users. So of course, then you need to know, well, how the hell do I run Chef? And when you're starting out with Chef, there's like at the very beginning, you kind of need to make a decision about whether you're going to be using Chef Client and Chef Server, or whether you're going to be using Chef Solo. So we ended up using Chef Solo, and the reasons for that are that Chef Solo is very simple. You don't have a client-server architecture. You don't need to worry about a lot of the globalness that you would need to worry about if you are working with clients and servers. However, like obviously Chef Server and Chef Client add a lot of things. The types of things they add are like with Chef Client, you can be searching for other nodes, so one node can find another node. It can do a lot more complicated. You can do things like you can be pushing recipes to the server, and then those and all those configuration changes can be pushed down to individual clients without you having to do anything manually. So with Chef Solo, you do have a lot more manual work, but all your configuration is on that machine, and it's a hell of a lot easier for you to understand when you're starting out. You know, like the basics of how Chef Solo works and how it like runs and all that kind of stuff are relatively easy to understand for you as someone who's not an expert. Anyway, that was weird. So if we were to break this down into problems, the first problem we had, you know, the reproducibility and the item potence and repeatability, all that kind of stuff. So Chef has that covered, you know. That's not really the whole story. There are always more problems. And the first problem that people really tend to ignore when they get into Chef is versioning. And versioning can take two forms with Chef. The first one is very obvious. The second one is a little bit less obvious. So I'll go ahead and demonstrate both of them. So the first thing is, let's take, for example, the Rvm Cookbook. This is the default Rvm Cookbook, and this is the default attributes. So if you look here, like it has, you know, the default Ruby, a certain version. It has an array of Rubies, and then it has the version for Rvm. So the first kind of version issue you see here is that if you were to create a machine using this cookbook now, and you ran the same stuff on a new machine in 2 months, there's a high likelihood that you would have a different version of Ruby because we're pulling from the version of head, right? So you probably want to reduce that. So that's very obvious, you know, like that you want to be pinning all these things so that you can have, you know, the exact same machine in 2 months. The other thing that's less obvious is that really all these cookbooks are just libraries like you would have in any other software development program. And so, you know, what do you do with your gems? You know, if you're testing something in your Rails application and you want to, and you run all your tests, when you go to production, you know, you obviously wouldn't be installing a new version of Rescue or something like that, you know, because you're going to be screwed, right? I'm just kidding. That was really mean. Anyway, I don't use Rescue, so delayed job is much better. Anyway, so basically you need to be doing this kind of versioning thing. You have the same issues you have with Chef that you have with other things. And so Riot Games created this thing called Berkshelf, which is basically analogous to Bundler. So the same way that you have something like a gem file and gemfile.lock, with Berkshelf you have a Berks file and a berksfile.lock. So basically with Berkshelf you would list, you know, your dependencies, and it would go down and it would find all the dependencies of those dependencies and list all the versions and download them to your machine and make all that really easy for you. So for us that kind of solved the versioning issue, so that we can have perfect repeatability. The next thing is that we needed a good development environment. So we needed to be able to create and destroy machines at will, because as you're doing cookbook development, it's really helpful, you know, to feel like, you know, if you make a small change and it's wrong, that you didn't just like screw up everything. So we use like Vagrant and VirtualBox, which I hope that most people are familiar with. If you're not, you know, Vagrant is a library that allows you to interact with provisioners like VirtualBox, and then VirtualBox is a free product by Oracle. That allows you to create VMs on your local machine. And so the two of them together, Vagrant can communicate with VirtualBox and then, so that you can, from the command line, you know, have really a good library into interacting with these things. So that kind of solved our development environment, so we could make mistakes at will. The next thing is that we wanted to be keeping it all simple. Using all these tools together can be kind of a pain, because as I said at the beginning with Chef Solo, you need to have all your stuff on the machine. So how do you actually get your stuff on the machine, right? I mean, are you going to be running like SCP or rsync or whatever to be copying all that stuff, and you have to be writing all these manual scripts and everything, or you have to know some other tools. But there's this great tool that someone created called Gusteau, and of course, you know, Gusteau is the chef in the popular Disney movie Ratatouille. So you know, everything in Chef has a food reference. So basically with Gusteau, it makes it really easy for you to be using all these tools together. So it's kind of a thin wrapper around Chef Solo. It adds some things to give you kind of a Chef client, Chef server kind of feel. And then it integrates really cleanly with Vagrant and Gusteau. I mean Vagrant and Berkshelf. So to make that, yay. So to actually make this work, we're going to make something called an omelette server. Really, I just you know, named this talk after an omelet, then I figured I should have a picture of an omelet, and I'm right before lunch, so I'll make you all hungry. But our omelette server is a really basic Rails application that might have RVM, might have users, and has Nginx, right? So basically to do this, if we wanted to start this, we would create a project using Gusteau, so we can say Gusteau init omelette cooker, and that'll set up a directory with some directories that, or with subdirectories, that'll be useful, and some files like Berkshelf and all those kinds of things, or Berks files. So we'll set up everything so that you can actually go into the directory and you can create, what the maker of Gusteau wants you to create very simply and quickly. So first thing is that we wanted to have these three components on there. So we need to go into our Berks file and we'll list, the three dependencies. So we have RVM, we have Nginx, and we have user. Now the Rvm Cookbook actually comes from GitHub, so it's really nice. In that with Berkshelf, you can be pulling things not just from the standard ops code website, but also from GitHub, so you don't have to wait for them to maintain it. I should say that one thing about Chef is that most of the ops code cookbooks are maintained by ops code, so they're usually pretty good. In the same way that like with Bundler, where you have at the top, you say that you're pulling stuff from Ruby gems, the same way here where you're pulling stuff from ops code. So we have these three things. So that's that describes the types our dependencies. The next thing is we need to actually make our run list. So this is kind of a shortening, but this is basically the meat of your run list. So it'd be these three things. And if you have those three things, then you just do vagrant up development web, and you say Gusteau converge development web. So this creates your virtual machine on your local box. And then it will actually converge on that, which means that it will run Chef, and Chef will decide what needs to run, and it will run everything. And at the end of that, you get this like nice little image where it says, Gusteau done, and blah, 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 right? So that's really cool, right? I mean, like in the span of, actually it took a while to build Ruby with RVM, but in the span of like, 15 minutes, you had an entire, like, mostly a rail stack. But of course, like that's kind of useless, or it's not useless, but it's kind of annoying because like ultimately when we were talking in the beginning, like with Klarna, we had lots of projects that were coming on, we had more people, so it's kind of silly for us to be copying and pasting all these run lists and doing all that kind of stuff. And on top of that, we didn't really solve the issue of the version with RVM. So the next problems you're really going to have is how do you share this kind of stuff and how do you keep from repeating yourself? So really, like when we're talking about sharing, there are two different types of sharing with Chef. First is sharing stuff inside your organization. So if you have common configurations, sharing all those common configurations between people at your organization. And the next thing is that getting stuff from the community. So if there's a problem, like for instance, if you're using CentOS, and there's an issue where the cookbook works at Ubuntu, it doesn't work in CentOS, maybe you want to push that change up to the community. Or maybe someone else made that change already and you want to be pulling that down into your system. So you want to be like optimizing for both of these kinds of things. So when I was talking about like a common example of what you might want to do is that if you have some attributes that you want to be sharing settings between people in your organization, so this is the same example I was showing before. So we want to be setting a certain RVM version so that we don't, so we have the same version from build to build, and also we want to have a different patch level version of Ruby 1.9.3. So a really naive way of doing that is that we could download the cookbook to our own site. We could upload it into our Git repository, and then we could be referencing that cookbook as opposed to the community cookbook. And so we could say that we want patch level 448, and for whatever reason we want to have two different versions of Ruby on this machine, and we want to be pinned to a specific version of RVM. Now the problem with doing this kind of thing is actually in this example it's pretty basic, but the problem with this is that if you get into more complicated things, you get into two different problems. One problem is that it gets into complicated merge situations where if you make tons of changes and then you want to be merging in changes from a community cookbook, that can be really complicated. The other thing is that it's very hard for you to tell what things you changed and what things were changed by someone else. I mean, obviously you can look at the git blame, but it's hard for you to know. It's hard for you to know the context under which things were changed and which little pieces you needed to change from the community because everything's kind of together, which is frustrating. So people have been using this thing called a wrapper pattern. Basically, the whole concept of a wrapper pattern is that you have a cookbook in between where the community cookbook and where you're using the cookbook. So with this wrapper pattern, basically you create a cookbook, which you can create with Knife. Knife is a tool that you don't use that much with Chef Solo. You can, but it has a hell of a lot of tools, but you don't really need to know them right now. But you just create a cookbook, which that's basically all that does is create a directory structure. There's nothing special about that. And then we drop it into the site cookbooks thing of our directory. And then we edit this and then we create a default recipe or default attributes that have the specific things that we want. And then we have a default recipe that then includes the RVM system recipe, right? And so then all we need to do is we need to modify our, we need to modify our run list to include that. Another thing to note when you're working with wrapper cookbooks is that you're testing your wrapper cookbook against a specific version of a community cookbook. So you want to be like depending on that specific version. And then, of course, if you wanted to update cookbook versions, community cookbook versions, then you can update that. Then you can see if your wrapper needs to be changed to work with it. And if it doesn't, then you can just blindly up it. If it does, then you can make those kinds of changes and bump a new version of your wrapper. So now you have like control over the versions of the cookbook that your enterprise is using. And then if you have some machines that are an older version, then they'll continue to get the same stuff. And if you have other teams that are on a newer version, they'll get the newer version. So that's all fun and games, right? So then all you need to do in here is just add this, like I said, into the run list, and this is your and this is what you get. So you just modify that. You do the same thing you did before. You might need to do Vigor and Up Development Web if something changed between now and the last 10 minutes, and you put your virtual machine down. But then you run Gusto Converge, and then when that runs, it will actually only end up making those changes. So it will actually only end up installing a new version of Ruby, and that's all it will do. So it won't actually go through installing Nginx again, but it will check to make sure there weren't any changes in the configuration. So that's pretty cool, right? Of course, if you went back and looked at the site cookbooks, that's not that would still be in your individual project. So you need to be sharing that. And it's really easy to share. With Berkshelf, you can be putting stuff into a Git repository and then referencing that. So all you need to do is take your wrapper cookbook, put that into a Git repository that's common for that everyone in your team can access, and then you need to actually tag it. So you need to have some kind of release management kind of tagging, which is not that complicated, but does require you to think about this stuff. And then in here, you're basically saying that I am dependent on version 0.1.0 of my wrapper cookbook, and then I can be sharing that between all my different teams. So then all my teams can be including this wrapper cookbook, and all the teams have the same version of Ruby, and life is good. Of course, the next thing so that's kind of most of what I'm going to talk about the specifics of Chef. The next things you might want to get into when you're talking about Chef are cookbook development. So you might want to be developing cookbooks that are specific to your particular company. So examples are like how to handle users. Maybe you want to write some stuff that adds people's SSH keys to different machines if you want to allow logging into them. Some other stuff is that you want to be sharing individual setups between teams. So like an example that I gave, like a really common pattern that you might want to do is that if you have a bunch of Rails apps and they all have the same exact setup, then there's no reason for you to be copying that same run list between machines, or between teams rather. So there are various ways to do that with Chef. There are roles, and then but roles are I don't know. I will share some links at the end that will show you how to do that kind of stuff. And then you might find at the end that you do want to be moving to Chef Server, which is totally cool, right? But the thing is that if you do move to Chef Server at this point, then you understand a lot of the basic concepts that get people into the broken byte kind of situation. So if you understand all these core concepts at a Chef Solo level, when you go to Chef Server, all you really have to be learning are all the new things you need to learn. So how to handle the globalness and how to make it so you don't affect other people's machines and all that kind of stuff. So at the end of that, hopefully you have a much better much better for it. So you get the quick value of Chef without the pain of living with your legacy decisions. Anyway, so to wrap that up, if you're starting to use Chef, or if you've already been using Chef, think about what you need, and then once you decide on that, use the tools that are out there that make this really easy. And then finally, you should always be building your solutions to make it really easy for you to iterate. And yeah, that's it. Any questions? And I should say at the end that if you go to my Twitter page, there's nothing on there. So I'm trying to get the most followers without actually tweeting anything. But I think I would probably tweet a lot of the links that I came up with for the slides. So anyway, if you follow that, you should see them later on today. Any questions?
Wow, no questions.
Must have sucked, huh?
You nailed it. You nailed it. All right, so thank you very much.
Thanks.